Tennessee's at-home learning series for math. Today's lesson is for all our sixth graders out there. All children are welcome to tune in. This lesson is the 20th in our series. My name is Reggie Caruth, and I'm an assistant principal here in Tennessee Schools, and I'm so excited to be your teacher for today's lesson. Welcome to my virtual classroom. If you haven't seen any of our previous lessons, you can find them on the Tennessee Department of Education's website at www.tn.gov/education. You can still tune in to today's lesson, though it may be more fun to go back and see previous lessons since we will be talking about things previously learned today. So today we'll be learning about area of composite figures in mathematics. Before we get started, to participate fully in our lesson today, you'll need the following: paper and pencil and a surface to write on, a calculator if you have one. If you don't, use the one on your cell phone. Y'all ready? Let's begin. So today we're going to combine the information we have been working on in previous lessons. To get us started, let's look at these three figures.
Okay, so based off of the three figures, what geometric shapes are we given? Yes, we're given a rectangle, a square, and a triangle. So find the area of each shape. I'm going to give you some time to do this. All right, so let's see how you did. So the area of the rectangle is length times width. So I know my length and my width will be 3 times 4. That's going to give me an area of 12 inches squared. Good job. So the area of my square, same thing, length times width. And then I do area 3 times 3, which is going to give me an area of 9 inches squared. And then I have my triangle. This is going to give me A equals 1/2 base times height. What's my base? 4. Good. My height is 3. So now when I multiply that, that's going to give me an area of 6 inches squared. You all did great. What operation would you use to find the total area of all three shapes? Do y'all remember that? Correct. I will use addition. So let's find the total area of all three shapes. I can do 12 inches squared plus 9 inches squared plus 6 inches squared to give me the total area of 27 inches squared. Good job digging into that memory.
All right, so today we're going to look at situations where we are asked to find the area of figures with multiple polygons involved. Ooh, right? Let's dive in. Today we're going to find the area of composite figures. Before we can find the area of composite figures, we must know what composite figures are and how we can work with them. So, what is the root word of composite? The root word of composite. Correct, it's to compose. What did we say in earlier lessons it means to compose? Correct, to put things together. Composite figures are sometimes called compound figures. Either way, they are figures composed of or made up of two or more similar figures. We will work with composite figures made up of triangles, which has how many sides? And quadrilaterals, which has how many sides? Let's look at a few figures and determine if it is composite figure, if it is a composite figure. I'm going to show you a figure. You tell me if it is or a composite figure or if it's not a composite figure. If it is a composite figure, tell me what polygon it is composed of. Y'all ready? Let's go.
So I want to know if this figure is composite or not. Correct. It's composite. Great. What polygons is in this figure? Correct. This figure is composed of triangles and rectangles. So I have my triangles. And then I have my rectangle. Good job. Let's try another one. I want to know if this is composite or not composite. Composite, good job. What polygon is this figure composed of? It's a trapezoid. We learned to decompose trapezoids into triangles and other shapes in earlier lessons. So it can be decomposed into two triangles and a rectangle. You remember that? So here's triangle 1, triangle 2, and then our rectangle in the middle. Y'all remember that? Good job. So now let's look at another one. I want to know if this is composite or not composite. Correct. The answer to this one is not composite. This one was a little bit easier to agree upon. So let's look at another one. Y'all are doing so good. Composite or not composite? All right, what's our answer? Good. I heard somebody say composite. So, since it's composite, what polygons is it composed of? Correct. It is composed of two trapezoids. And what figures are trapezoids composed of? You got it. They're composed of triangles and rectangles. Y'all are really getting this. I'm glad you remember. Let's do one more together. I want to know, is this composite or not composite? Good. It is composite. What polygons is it composed of? Correct. Two rectangles and a triangle. Before we begin finding the area of composite figures, look at the examples we have given. What are similarities and what are some differences based off of the examples that we just went through? All right, some similarities is they all are composed of polygons. That's one similarity. They all are big figures. That's another similarity. The right angles are marked with the right angle symbol. That's another one. And the units are the same. What are some differences? They are composed of different combinations of polygons. Correct. That's a good notice. I also heard somebody mention the right angle symbols. Why are the right angle symbols important? I agree. They are necessary for determining the shape of each figure and the dimensions of each figure. I also heard someone else mention that the units are the same. So that's a great catch. Why do you think this matters? Good. As we calculate with these figures, we must make sure we are working with the same units within the figure. If we're not given like units, we must convert them into like units before we can combine values. So let's keep that in mind as we move forward today. Let's go work on some composite figures.
We're going to work together to find the area of composite figures. We do not have any new formulas today, but instead, we will be using the formulas that we have worked on in previous lessons to bring it in and tie it together. Let's review those before we get started, so we will have ourselves a list to work with. Make yourself a list to recall all of the formulas that we've worked with in the past.
All right, so what polygons have we worked with? Correct. We've worked with rectangles. We've also worked with parallelograms. We also worked with triangles, good. We also worked with regular polygons. Good job. So what are our formulas for each of these? All right, so our rectangle and also square, so I'm gonna put square in parentheses that we worked with, because we work with squares, is area equals length times width. What about parallelograms? Correct, that's area equals base times height. What about triangles? That's area equals 1/2 the base times height. And what about regular polygons? That is your area, and that equals the area of one triangle times the number of sides. So let's do some examples. You may use a calculator, but it is not required. So let me erase this and we can get started. All right, so here's our first example. I want you to find the area of the given figure. So where should we begin? Correct, we must first decompose the composite figure. This means we must break the figure apart into smaller pieces. So what polygons is this figure composed of? I agree, 2 rectangles and a triangle. So let's start with the triangle. So we're gonna start looking at our triangle first. And I know working with my triangle, my formula is area equals 1/2 the base times the height. So I'm gonna start filling in what I know. What is my base? Correct, it's telling me that my base is 9. What is my height? I heard Brooke say 10. How did you know that? Correct. Great job. Because she knows that these for my square or rectangle are parallel to each other. So if this is 10, this must be 10 as well. Good job. So 10. Now I'm ready to solve. 1/2 times 9 times 10 is going to give me an area of 45 feet squared. Good job. So now let's move on to one of the rectangles. I want to go with this one next. So I know that find the area of a rectangle is area equals the length times the width. So what do I want to substitute for my length? 10, and my width, 13. So my area of this rectangle is 130 feet squared. Good job. So we have one more figure to work with. So now let's find the area of our second rectangle. Area equals length times width. My length is going to be my what? 10. My width is going to be what's my width going to be? 8. Something's up with this. I want to see if you can correct what we need to fix. What's incorrect? Good job. You notice that my length is incorrect. But what is incorrect about it? Because the length of this total side is 13 plus what? 9. So to get the correct length, I do 13 plus 9, which is going to give me 22 times 8. Good job and good way to correct that mistake. Okay, so now are we ready to find the area of this rectangle? Yes, we are. So area equals 176 feet squared. So I know that this area is 176, this area is 130, and this area is 45. So now that we have the area of the decomposed figure separated into two rectangles and a triangle, how can we put them all back together for a composite figure? Correct, we can add them all together. So I can add 176 plus 130 plus 45 feet squared for each of them. When I add those together, that's going to give me 351 feet squared. Y'all did great on that. That's a good job. Let's do another example together. I'm going to lean on you for some help on this one. All right, so find the area of the composite figure. So I want you to take a moment to decompose the figure to determine the polygons in this figure. You're right, there is one triangle. So one triangle and two rectangles. How do you know that they are rectangles? Correct, because they have 4 right angles. Good job. So separate the figure into 3 pieces. Wait, I just had someone just ask a great question. Since the 2 rectangles are the same size, can we find the area of one and then double it? Absolutely, that's great thinking. So before we start finding the area, are my units the same? Yes, they're all in feet. So we can go ahead and start finding the area. Let's start with our triangle. So let's start finding the area of a triangle. So I know my formula, area times 1/2 times base times height. I can go ahead and start substituting what I know. So my area, what's my base? This is a good one. What's my base? Good, my base is 13. Why is it not 3? Correct, because this 3 is just a piece of the base, and the other pieces are equal to 5. So 5 plus 3 plus 5 is 13. Good job. What's my height? 4. So now I can solve. 1/2 times 13 times 4 is going to give me an area of 26 feet squares. How many of you got that answer? Good job. I heard a couple people say 6 feet squared. Let's see if we can figure out what you did. What did you use as your height? Correct, you used 4. What did you use as the base? Some of you used the 3. And so, going back, looking at my figure, 5 plus 3 would give me the whole line, which is 13. So now let's find the area of our rectangle, or rectangles. So again, since we know that both of these are the same, I can just double it to represent that one. So my length is going to be 5. My width will be 10 to get an area of 50 feet squared. So how do I use these two calculations to find the area of the composite figure? The composite figure has an area of 26 feet squared plus 50 feet squared plus another 50 feet squared. So I can start adding together. 50 plus 50 plus 26. So my composite figure has a total area of 126 feet squared, or square feet. Good job. Let's try another one. Y'all are really working this out. So find the area of the shaded region. So we're going to find the area of the shaded region. So how is this problem different from our previous problem? Good observation. One of you said that instead of having a square attached to the outside, it is cut out of the middle. That is a great observation. We can summarize that to say the rectangle is composed of a square. So someone else said that the units are not the same. That's a good catch. We need to address both of these in our observation. So let's first start with our units. What two units are we given? Correct, we're given inches and feet. And remember, we talked about this before. Our units of measurement has to be the same. So we're going to convert our 1 foot into inches. So let's convert. I know 1 foot equals how many inches? Correct, 12 inches. So this is the same thing as me saying 12 inches. So the other observation was concerning is that the square in the inside. We need to figure out how to take the area of a square out of the figure. What operations allows us to do that? I agree, subtraction. So we would have to use subtraction in this one. So what is the problem asking us to find? The area of the shaded part. So what does that mean? So to get the area of the shaded part, that's the area of the rectangle minus the area of the square. So since we need both areas, let's take a moment to find those two areas. I'm gonna give you some time and then we'll check our work together. All right, so we're gonna check our work. So we're gonna start off with the area of our rectangle. We know our formula, length times width. I can substitute 12 inches, remember not the foot, the inches, and 6 inches to give me an area of 72 inches. So the total area of this is 72 inches. So now let's find the area of this square. Same formula, length times my width. That's going to give me what? Good job, 9 inches squared, and this should be squared as well. So now, going back to what we discussed earlier, we need to subtract the two totals to get the area of the shaded regions. So I'm going to take 72 inches squared, and I'm subtracted by 9 inches squared to give me the area of the shaded region of 63 inches squared. Woo, that's some good work, y'all.
Today, we have spent time working with composite figures. To find the area of these figures, we have had to decompose them into separate polygons. We have used area formulas in previous lessons to help us find the area of composite figures. Before you go on your own, I want us to do 2 more together. In this part, if you go ahead of me, go for it. I want to make sure you're able to find these areas by yourself.
So, looking at this problem, where do we begin with this one? Yes, we have the same units, so we can begin there. We should decompose the figure into separate polygons. Take a moment to see what polygons the composite figure contains and write down their formulas, the area formulas. Let's see how you did. We know that this composite figure has one rectangle and two triangles. We also know that find the area of a rectangle is area, length times width, and find the area of triangles is area equals 1/2 the base times the height. How did you do? Good job. Now take another moment to find the dimensions of the rectangle. Correct. The dimensions of the rectangle is 7 is my length and 12 is my width. So now I can start substituting what I know. "84 meters squared." So I'm gonna also write it here so I can know. Let's do the same thing with our triangles. So the height of our triangles is 5 meters. So we know our height is 5 meters. Can anyone help me out here? So if the height is 5 meters and the base is 12 meters, Randy just said that she got 6 meters as the base. Why is our base not 6 meters? Can we rephrase this to help out? So we will rephrase this to help her out as we also have to look at the dotted lines. And we see that it is a total of 12. So our dotted line is a total of 12 because we know that this is parallel. So I'm gonna write 12 here. That's what our dotted line represents. So I can do 12 plus what to get me the length of my side for my triangle. So since the dotted line is 12, if I add 6 plus 6, that's going to give me 12. It's going to give me a total line of 24. Since my triangles are the same size, I can have that to know that this side of my triangle is 12, and this side of my triangle is also 12. So that I know that in my formula, area equals 1/2 the base times the height. I know that my base of my triangle is 12. The height of my triangle is 5. So now I can multiply. When we multiply this together, that's going to give me an area of 30 meters squared. Good job. So I'm going to write that here. Good job. Are we done? No. So now we have to find the area of the composite figure by adding up the area of each. So I have 30 meters squared plus 30 plus 84. That's going to give me a total area of this composite figure of being 144 meters squared. Good job.
All right, so great work. Today we reviewed the area of composite figures. I hope you're seeing some connections to finding the area of polygons to composite figures. You sure did do a great job. After the video, you'll have some independent practice that you can try on your own. I'm going to show you those now, or you can find them on www.tn.gov/education. Good luck and try your best. I really enjoyed reviewing the area of composite figures with you today. Thank you so much for inviting me into your home, and I look forward to seeing you at our next lesson of Tennessee's At Home Learning Series. Goodbye.